in the TREE consortium, which is Transfer, Exposure and Effects. It's funded by the National Environment Research Council, the Environment Agency of England, and Radioactive Waste Management Limited. There's 7 higher education institutes and 10 or 11 partners, some of whom are regulators, involved in the consortium. We have a number of postdoctoral workers and quite a lot of PhD students, and we're trying to use specifically the Chernobyl exclusion zone, where there's radioactive contamination, as a kind of a field laboratory for doing a whole kind of complementary set of environmental radioactivity experiments. So some people look at soil and the long-term behaviour of radionuclides in soil, because even though the radioactivity's been in the soil at Chernobyl for a while, it's still only 25 plus years, and if you're interested in the really long-term behaviour, you need to know what's going to happen over a longer time frame than that. So there's some soil people, but then there's lots of people looking at invertebrates, there's lots of people looking at mammals and the effects of radioactivity on mammals and on mammal kind of ecology in the Chernobyl exclusion zone. But then we do the plant bit. We're looking at how plants take up the radioactivity, the kind of levels and the isotopes that you get at Chernobyl. And all of us together are trying to look at a series of set endpoints of effects that the radioactivity might have. So we're trying to make a big effort to look at fluctuating asymmetry in particular in a number of different groups of organisms, because as organisms develop, most things don't develop perfectly symmetrically, although that's the kind of perhaps the optimal development scenarios. Things will develop perfectly symmetrically. In practice, if there's variation in the environment, things develop a little bit asymmetrically. And if there's a stress like environmental radioactivity, you tend to get a kind of an enhanced fluctuation in the asymmetry of organisms. But that's a useful endpoint to measure, because you can measure it in a whole load of different organisms, both animals, plants and other things. So we do the plant bit on this consortium, and other bits of the consortium are looking at the transfer from the soils, the movement up into all sorts of other organisms, and together we're trying to look at the effects on a whole variety of different organisms. Because overall, even though there are quite a lot of reports of effects of radioactivity at the Chernobyl exclusion zone, not only are those often not very well followed up with experiments under controlled conditions. Often the individual organisms that are looked at, their exact doses, the doses that they actually got, are not very well examined. So lots of the things that there are lots of things that migrate in and out the Chernobyl exclusion zone, and so lots of studies don't take particularly good account of the migration of organisms in and out. So on the consortium, we look at the effects on plants, the transfer to plants, but there are also some other people that are looking at dosimetry and trying to work out much better ways of estimating the doses that organisms at Chernobyl are actually getting. So at the end of all this, we hope to be able to say something about the transfer and effects of organisms at a kind of an ecosystem level, with a bit more kind of accuracy and a bit more insight than has previously been possible. Our research in the last few years has made quite significant progress in being able to make predictions, because we've used new models of the evolutionary history of plants to try and map lots and lots of information that we've generated and also that other folks have generated for uptake of radioactivity. So we've got a much better hold now on which groups of plants tend to take up which isotopes to high amounts and which isotopes to low amounts. And our research on the effects of radionuclides is very interesting, because I think for the first time we've got data sets now for what happens to plants when they are exposed to radiation under controlled conditions for multiple generations, and there's surprisingly few reports in the literature of what's happened under controlled conditions through multiple generations of exposure. And we've got some interesting data sets now of plants that we've grown in the laboratory generation after generation after generation in Chernobyl levels of radioactivity. And we've measured lots and lots of different things about those plants, their fluctuating asymmetry, some things about their morphology, some things about their physiology and their anatomy, and those are kind of unique data sets that will provide us with some insight about what the effects of radiation are at chronic low levels over multiple generations.